I had a dream, got everything I wanted. We're going to go ahead and start chapter 4, triangles. So this chapter has everything to do with triangles, which seems pretty basic because a triangle just has 3 sides, but there's so many properties in a triangle. So this chapter is going to be full of information. All right, let's go ahead and classify triangles by their sides, how big their sides are compared to each of the sides. For example, an equilateral triangle. Equilateral triangle, if you see, look at the root word, is equal. Lateral meaning sides. So equilateral means equal sides. All sides are equal. Isosceles. This one's a hard one to spell if you ever had to spell isosceles, but it means exactly 2 sides are equal. And then scalene, no sides are equal. We can also classify triangles by their angles. For example, an acute triangle has all of its angles less than 90 degrees. An obtuse triangle, not all of the angles are more than 90 degrees. Only one angle is more than 90 degrees. It is impossible to have more angles in a triangle that's more than 90 degrees. Only one angle is more than 90 degrees. A right triangle, that's when one of the angles is 90 degrees. And then this is the last one, is a special one, an equiangular. That's when all the angles are equal. And then if you know the property for the triangle sum theorem, whenever you have a triangle, all the angles on the inside have to add up to 180. So if all the angles are equal, then each one must be 60 degrees. Because if you add 60 and 60 and 60, you should get 180. All right, let's do an example. Here we have an example of a triangle. Actually, if you're good, you can see that there are actually 3 triangles in this picture. You have this small one right here. You have this slightly bigger one over here. And then the entire picture is another triangle. So we actually have 3 triangles in this picture. All right, let's go ahead and find all of its angles. All right, so the first thing you should see is there are these red tick marks, and they're important. A lot of times you cannot just look at a picture and be like, oh, that looks the same, so I'm going to say they're the same side. That's not the case. You have to look at the tick marks. The sides are only equal if the tick marks are equal. Okay? And so in this case, this triangle here, BDC, it looks like it's all the sides are the same because they have tick marks all the way around that are the same. And so we have an equilateral triangle, and we're going to find the angles on each side. Remember, we talked about equilateral and equiangular. If all the 3 sides are the same, then all 3 angles are the same. So that angle is going to be 60. This is 60, and that's 60. All right, another marking that is important is this little box that's in the corner. That denotes that we have 90 degrees. If there's no box, you cannot assume that it's 90 degrees. Only if there's a box. In this case, we do have a box, so it is 90 degrees. Well, if the bottom part is 60 degrees, the top part of it must be 30 degrees, because 30 plus 60 is 90, complementary angles. All right, next thing we want to look at is, how about this angle over here? It is supplementary to the 60, and so we have 180 minus 60 is 120. And then and then the last angle we need is this angle. Okay, and then we have a triangle here. All three of them have to add up to 180 degrees. If we have a 30 and a 120, then angle A must be 30, because all of them have to add up to be 180. All right, so we have filled in all of the angles. Let me clean it up just a little bit. Here's the 120 that was supposed to be there. All right, once we got all the angles, let's classify. We have to classify them two different ways, by its angle and by its side. So for example, if you look at triangle BCD, this is triangle BCD down here. We have to classify it by its angle. Well, all the angles are the same, so we have equal angular, and then all the sides are the same, so we have equilateral. Oh, and then of course all the angles are less than 90 degrees, so acute. Equilateral is a better answer. How about triangle ADB? ADB is this triangle on the side. Notice that one of the angles is more than 90. So we know it's going to be obtuse. And then notice only two of its sides are marked equal. So when only two sides are marked equal, we have isosceles. So obtuse, isosceles. Okay. And then the last triangle we're going to look at is triangle ABC, the big one. Let's look at the angles for the big one. This one is 30 degrees, this one is 60 degrees, and this one is 90 degrees. Again, if we have one angle that's 90 degrees, we have a right triangle. And then what about the sides? Well, the numbers are not given, but you have to look at the markings. This has one dash. This one has one dash, and then another at one dash, which means it's going to be twice as long. So they're obviously not the same distance. And this one has no dashes. And so when we have all three sides different, we have scalene. So it's a right triangle and a scalene triangle. So you have to name all of them two different ways. All right, let's move on to some algebra. All right, algebra is fun. It's kind of like a word problem. It says triangle XYZ is an isosceles triangle. Isosceles, two sides are the same. XY and XZ are congruent, and then XY, and then they give you some algebraic equations or expressions. So the first thing you really want to do is draw a picture of an isosceles triangle. That looks like an isosceles triangle, but you have to mark it properly. You have to put X, Y, Z, and it says XY and YZ are congruent. So those two are congruent. All right, so drawing the picture and labeling it correctly is very important. Now we're going to put in XY is equal to 3x plus 7. And then we're going to put XZ is equal to 9x minus 17. And then we're going to put YZ is x plus 5. All right, once we do that, we're going to have to solve for all the sides. And the way we do that is we have to see which two are equal. I already jumped to the gun, but only these two are equal, and that's why I have it set up that way. This is not equal. All right, so if we set those two sides equal to each other, use your algebra skills to solve do a little bit more, and we have x equals 4. Now, if they ask you to find the lengths of each side, you actually have to plug the x back in. So if you plug the 4 back into this x, you get 19. And if you plug it over here, you should get 19. And then finally, we're going to go ahead and plug it into there to get 9. All right, so that's basically the homework, mostly just definitions, again, with classifying the sides and the angles, but go ahead and start the homework.